the other video, so I lost all that information, but that's a-okay. So, okay. Now, let me know how the update rate is, because I've got no idea. All of these are broken and ugly. I need to fix them. Good enough. Alright, so what do we need to do here? Unfortunately, I have messed up the goofy flip-flops here, so I need to figure out what goes where now. So, 2 goes to 6, 2 goes to 6, but not 5. So we need to move that up, and we need to move that up. I guess we need to delete everything here. So, 2 goes to 5, and 8 goes to 12. 8 goes to 12. What is 12 connecting to? Also, 12. Okay. Is 12 a clock pulse? No. A clock pulse is 3. So this line needs to get deleted or removed. Alright, so hopefully, with any luck, that should have improved everybody's experience, even though it's very silly. Okay, good deal. Thank you for all your support. It is most welcome. I know you want to improve the quality of the streamers here. I'm sorry I'm not going to be really coding much, but, you know, quite frankly, I'm here because I lost the ability to stream on certain things, you know, Twitch or Justin TV. Justin TV, you know, they just out and left. And so it left people like me who, well, I'm mostly a hardware guy, and my projects currently are a little weird. I'll be coding eventually on here, but my primary thing is just for a place to outlet my projects and my current hardware hacking. So, let me actually show you what I'm up to. This started out as, you know, I own a bunch of vintage computing systems and such, and I needed a way to connect them together and hopefully get them on the internet. So I decided to use modems because they're available for, you know, like Commodore 64s, 128s, etc. And also my old PCs. And so I need my own phone company. And when I made my own phone company, using Asterisk and you know, just basic Linux hardware and ATAs, you know, that you can buy at the store, you know, Vonage, Basic Talk, things like that, or even more advanced things like Cisco SPA112. I found I could connect my modems together at 9600 baud, which means that I effectively have a way to get my vintage computers online, which is pretty cool. But during that, I went down a rabbit hole I wasn't quite expecting to go down, and that was related to phone phreaking and stuff like that. And I found that a lot of my interests intersect. So I'm actually gonna try and show you what I've been up to. We're gonna give this a shot here. Let me get OBS up. And we're going to add a, sorry, pardon my mess, it is a mess. View capture device, create new. Alright, so, yeah, that should work. And so what I've been working on, we got a Western Electric telephone here, and apparently I need to go out and find out what wire I tripped over, because we're not running right now. So give me just a moment here to figure that one out. But basically, it ended up with me with a schematic that I wanted to build in real hardware, and I've been working on that for a couple of days now, sourcing all. This is the old way of coding things. You take a frequency from like a 1 megahertz crystal, which, let's see if we can, and then you divide that down to 125 kilohertz, and then you take whatever you need to do, and because blue boxes use MF tones, which is to say multi-frequency, it needs 2 tones per key in order to do something. The only thing that's different is the 2600 tone, which I'm sure you've heard 2600 thrown around in hacker terms, but that's actually what resets a trunk. And I'm going to show you what that sounds like using something called Project MF, which is a real cool project that exists, created by another phone freaker. And we're going to plug this sucker in. Need to recrimp the jack on it, I guess. And, well, let's just have a skiz, as it were. Let's see. Don't know if you'll be able to hear this, but let's see. This won't sound like a normal dial tone. I've been trying to recreate the old Bell system dial tone, but it hasn't worked. Let's see, did I get it? Don't think I got it. Let's try it again. Okay. Oops. Okay, so hopefully you can hear this. And I've got a blue box emulator here. It's going to be a really loud noise in a second because we're going to blast it with 2600. And you hear it reset. So, I need to reset again. So we're going to go key press 1. And those are actually MF tones. So that's what this box is actually going to create. Oops. That's not very nice. But yeah, we're actually hooked up to a trunk via Asterisk and Project MF now. Let's see if I can find something more amusing here. No, wait, that just resets the trunk. But anyway, you get the point, right? It's just a lot of fun and screwing around. So what I've done is, this is Steve Wozniak's original blue box schematic, well, you know, a copy of one. What I've been doing is using modern equivalent part numbers to actually build it out. So I started breadboarding it yesterday, but I ended up in a failure because I didn't understand a part of his schematic. So I'm sort of redrawing some of it so I can understand how it's going to lay out on my prototype board. And we'll go from there. So let me, we don't need to have this on anymore. So I hope that tells you what I'm up to. Let's see here. Anyway, the point is that I lost Justin TV as a place to outlet my projects to, and I got banned on Twitch for a month for not streaming gaming. I don't like Ustream a lot. I've been using it, but it inundates pretty much everyone with ads, and they don't like it very much. Stream Up started out as a really cool collaborative thing, and I liked it a lot. And when Justin TV left, they redid it. They took all the accounts and channels, they merged them into one. They made a mash of their database, and embedding is disabled, and that's something I'd actually want to do. I've got to actually go in and recode. We got an IRC channel on Freenode called Geek Streams, and we actually like to what's the word for it? We like to show off each other's projects as we're streaming them, and I'm hoping this can be a good replacement for it. But you know, I need someone to code that, because Geek Streams is kind of a mess of Python and ugly. Python and ugly. And Node, too, for that matter. When I added Stream Up to it, I don't even know how I did it. I had a lot of help. But I'm just rambling. Why am I rambling? I should be working on the schematic. Streaming things makes things take longer. It is a fact of life. Okay, where was I? So if there's anything, it would be nice if you guys had embedded code. Speaking of which, TileBot's back at least. No. Good. Okay, where was I? So, just so you know, for anyone who's actually watching this, I don't know why you'd be watching this, because it's, like, boring. But, here's what we're actually doing here. I've got, this is Woz's digital blue box schematic. This is his third design. Let me see if I can get it in frame here. And I'll just leave it there so you can read it. And while that goes on, I will search my friends and see if anybody wants. Check XMPP chat. Alright. Thanks. Okay, so hopefully that shows you an overview of what I'm actually trying to do, and we're going to go back to trying to do it. So, this is not for a board layout, it's not for anything, it's just pretty much so I can understand what's going on. So, alright, we're going to go and zoom into the flip-flops, dual B flip-flop, and get it. So pin 11 is going to connect to the clock, actually. So we'll pull a clock out. Is that right? Yeah, pin 11 goes to clock. Pin 3 goes to clock. Oops. That's not right. That doesn't go to clock at all. Neither does that. but 11 goes to clock, 3 goes to clock. This goes to pin 2. And quite frankly, we can just alleviate that right there, because it doesn't need to be there. And pin 11 goes to 12. 11, no, that's not right. That's not right. No, 8 goes to 12. 8 goes to 12. So we need to go here. I'm sure this is like watching like a 2-year-old do this, but bear with me. Okay, so that goes to there, that goes to there, and off of there, one goes to 2 and 6, and 2 goes to that one. Cool. So that goes to there, that goes to there. That is not a straight line at all. Maybe I can make it straight. Maybe not. Oh yeah, we need to get back to... Okay, so the clock is set. Clock is generated from here. I need to add another point to it, to be honest. So we're going to do that here. We're going to also do that here. And cool. Okay, that's better. So the clock goes in, the clock comes out, the clock goes all over, whatever. Doo-doo, 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 doo-doo. I really want that to be a straight line, but it's not. Okay, so let's follow the schematic. We go from our crystal, we go into our 8284, which is now 74LS193. We come out, and we go into the clock. And the clock hits, let's just go over A1, which is over here. So the clock hits A1. And it should hit it. Okay, so we're not done yet here. We're not done yet here. So, pin TC is pin 15. So pin 15 is the counter out. On A1, we want A1 goes to, where does it go? 15 on A1 goes to 10 on A2, or B2. So this goes to there. And likewise, on the other side, B1 connects up to B2. So let's see, B1, pin 15. Oh, okay, good. Goes up to 10. So we'll do that. So that makes sense. So let's see if all our pins are accounted for. So B1, we've got 2 and 10 connected. 2 is connected. 10 is not. 10 is, what is 10 going to? Oh, wait a minute. Sorry, I was looking at B2, not B1. B1. So actually, let's look at B2 first. B2. So pin 2 is connected. Pin 2 is connected to clock. Three, 4, and 5 all go to the actual diode matrices. So 2, 3, and 5. I don't have to care about that yet. But there's our, wait a minute, 3, 4, and 5, I think. 3, 4, and 5, yes. 3, 4, and 5 go to the matrice. So we don't have to worry about those. 2 and 10, 10. Why is 10 not connected to anything? Did I mess it up? Oh, I messed it up again. Okay. B2. B2. B4 and 5 go to the matrice. 2 is connected up to clock. $11 gets ported over to the... Interesting. Did I mess this up again? I must have. Because... yeah, I messed it up. Totally messed it up. Oh wait, I didn't put those in yet, did I? Ah. Cool. Because that's the clock, so it doesn't matter. I think it doesn't matter. Wait a minute. Wait a minute here. I think. I think the clock pulse doesn't go to all those things. She makes it look like it does, but I don't know if that's the case. No, that's not the case. So, his clock pulse only goes to... But he is so good about... So I think there's actually a break. Well, that's my fault. So that is correct, at least. But what isn't correct is the input. The input is not correct. So we'll have to do this again. So it's okay. So I think the clock pulse is actually separate from whatever connects 9 up to everything else. So we need to break it. We don't need one here. 9 doesn't connect to the clock as far as I know. That doesn't make any sense. So 9 gets tied with 11. 9 gets tied with 11. Only on this one. So we also have to remove that wire, and by virtue of removing that wire, we have to remove not that wire, but that one. So where does that leave us now? Good question. Again, on A1 and B1, we got to look at A1 and B1 again. And we need to get rid of the connection to the clock on 9. And we need to get rid of the connection to the clock on 9. So we need to do that. So let's see. wonder if a jumper is in the symbol manager. I just want... Oh, cool. Wish I'd seen this earlier. But even that's not what I'm looking for. Let's try this. This is a bad way of doing it, but... Oh. Yeah, I guess. Oh, that's connected now. That's not good. Not good at all. Let's just see. So I've gained a much better understanding of this original schematic. Now I know what's going on, and I know how my parts differ. So I'm happy about that. Now, how do I make the cow jump over the moon on Express SCH? That is a good question. So I need to get 10 to 15. But at the same point, I guess that'll do. And we do the same thing here. 10 to 15. And we're going to insert corner because this is not an elegant way of doing it, but whatever. Let's see. I guess I could take it back one whole pin, make it consistent. So that's good. That's good. That's a bad way of doing it, but we did it. Fillet would have been better. So let me at least get this part of the circuit designed. So the clock comes in, goes to pin 2 of everything. And then from there, it gets divided down. So let's actually go to B1. So, let's go to B2 first. B2, which is the top one. So we've got pin 3, pin 4, pin 5, and pin 6. And that corresponds to let me just make sure this is B2. So pin 3 corresponds to 2. Three is B3. I'm going to make that way smaller. Let's make that 1.27, I guess. That's as small as we can make it. 4 is B4. Before or after, I don't know. And B3. B3 is not B4, it's B2. Unfortunately, oops. B3, B2, B1. So B3. Is that. B2 is pin 4. We actually don't use pin 6 on this chip. Oddly enough, we don't. Now so B3, 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 B2, B1, 4, 5, 6, 7. But yeah, I think I can actually go out and build this now and feel confident that, well, it might work. But let's just continue this. So let me actually copy this and paste it. Good enough. We can try. And instead of B3, this one on pin 3. Oh. This one on pin 3 is actually okay, pin 3 on B1 is B7. Pin 4, B6, B5. And this one will obviously be B4. So, what does this mean then? It means that I am a very confused person. Also means bloop, 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 bloop. Okay, so that's that. Let me see what 0 is up to. Stream Okay. It occurs to me that I should pull those back a bit. Because those will all fit within. So we're going to do the same one to A1. And that one's, okay, so A1. A1 uses, okay, is it A2 or A1? That's A1. So A1 uses A7. Wait, are these Q's or, I don't know. No, so we'll find out. A7, A6, A5, A4. Not be confused with paper. Okay, Control V, X, escape. Didn't mean to do that, that's a mess. Okay, that's fine. So we got that set up. Now these, this is A2, so A3, A3, A2, and A1. Go here. And pin 6 is unused, so this down one, this down one, just so many to move down one. All for one change. But it was worth it. Okay, so there's our inputs and our output. Now we need to connect the two. So, pin 3 and 11, where do they go? 11 comes off of that one, so we need to look at our B2 and our A2. That's what we need to look at. So B2 and A2 up here. A goes to 1. We're actually going to delete our 34LSOO so we can reconfigure it just a little bit. Alright, so we need a 0, 0 NAND gate. And we need to put it in. Let's see, like how. The B2's on the left. Let's actually put it facing down. I want it upside down, I think. But I've already got that chip there, so. Right, let's just do it that way. Okay, so B2, what pins get connected on B2? All the 9s get connected together. So let's just do that now. So 11 goes to our flip-flop on both sides. The 11s, no, they're not connected together. Which is okay with me. Let's just leave you down there. But 9 also gets connected with 11, so pull you over here. Go hopefully around. And into there. So we need to make some more room. So 9 gets connected to 11. That looks good. Also, the same thing happens here. Now here's where it becomes important to not mess this up. Oops. This is the A side. The A side gets fed into number 1 of the NOR gate eventually. So it gets fed into pin 3. I just came up with a new way to make my schematic look a little better to me. Okay, so I think I can also afford to lose a few pixels here. And so that one goes to there. And I should just, you know, that would make a lot more sense if I just did it that way. So we're going to do it that way. We're going to come down from here. Go up to here, then back down to here. I'll fiddle with that later. Down to here. Over to here, and then we're going to make the final connection there. Okay, so what have we got then? It says 6 goes somewhere. Indeed it does. So the question is 2 to 6. So 2 to 5. Why I have it going to 2 to 5? Should go to 2 to 6. So let's find out why I had it set to 5. 5 isn't in there. Alright, I am happier than I have been, so that's good. Insert point. Oops. Okay, so we need to delete that one, put this one in there, and make file connection. Good. Okay, so I can do that to every one of these actually. And it'll make me a much better person. This is not the right way to do it still, but I don't care because it's getting the job done. So that is good. Oh yeah, I did say I was going to fix that, and I didn't. No, don't merge. No, don't merge. Good enough. So I can fix all these now. Such is life. Oh. Actually, I can't fix that one yet because it's uneven. Maybe these are a lost cause. Okay. Yeah, I guess these are just a lost cause for now. I know what they do. So, what next? Let's follow the circuit. We go from the crystal into the 74LS193, out of the 74LS193, into the clock for everything. What? Oops. Almost into the clock for everything. B1, we made a mistake. Because 2 should just be clock. 11 isn't even connected to anything. No, it is. Okay. But 11's not connected to 2, that's for sure. Is it? No. 11 is not connected to 2. We have made a massive mistake there. So the question is, what's actually connecting to what? B1 should not have anything, or B2 should have stuff connecting to it. And so should A1. not, but not this one. This should, B1 should not be connected to any B1. Yes. Should not be connected to anything on pin 11. But the clock should still be connected. So where am I getting the clock from that? Up, around. Okay, there we go. So up, around. Okay, so let's look at let's examine this one more time. Okay, our clock gets generated, clock up, Q3 over, and it feeds the clock for 1, 2, 3, 4 chips. Each of these chips has 2 connections. CP and C. So B1 has 2 and 15 connected. 2 is obviously connected because it's clock pulse. 10 is, wait a minute. Clock? No, that's right. That's right. That's right. So that makes a lot of sense. Well, as much sense as it can. Not done well at all, but we'll get the job done. So, what's going on? We've got, okay, we got our 1 megahertz crystal going into our counter, coming out of our counter, feeding the clocks for those 4 counters. Those 4 counters each have those inputs. Those inputs, in turn, determine what comes out of both B2 and A2. A2 that makes sense. Those go into the flip-flops. Flip-flops feed the NAND gate. Okay, so I think we're back on track now. Back on track. So, of the logic units that we have, we've got flip-flop down there. Let me actually look at my board layout, because I'm trying to emulate the board layout if I can. We have 2 chips to the left of it, so let's make a little bit of room for that. I don't have a lot of room, but we'll make it anyway. So let's actually get our other chips involved. This stuff, I don't even know. You guys need to float around, but Z, undo. Man, that's close. Okay, all of you this time need to go over yonder for the moment while I think about what to do with you. So what I don't have in layout yet is our 1820 0068 NAND gate. That's a 7410. And let's see, where is it going to be getting? Where is that going to get its stuff from? So if we look at the 0068 chip and find out what it's doing, it's mostly dealing with the diode logic, but let's just put it in anyway. We'll flip-flop it upside down. Where does it get its inputs from? That's the question. Oh, okay, A. Is it from the A's? Okay, well, we can deal with that. So that's one of the chips we're missing. And the other chip we're missing now that we've got that chip, so we got the 77 as the dual flip-flop. Got it. The 0054 is the first NAND gate, and the 0068 is the second NAND gate. So we've got all of those on the board layout. We've got our 49316s, which are, I'm using 161s. Oh, it's 24LS 161s. And now we need more. So the other two chips are 8H90, which is a part of that. It's part of the diode logic too. I think I'm going to put the diode logic on a different page actually. Done. So let's see. The question is, are all these chips wired correctly now? So let's go from the top. Let me actually pull a side by side here. Let's see, 875. So we've got a full oscillator, so we don't have to worry about it. But he's actually got it self-oscillating. And so he's got, this is his counter right here. I'm substituting a 74LS 193 up-down counter. It's the wrong chip, but it still should work fine. And so the pinouts are different. And then from there, it goes, the clock goes into these four chips. And these are binary counters, 4-bit binary counters, 9316s. So 1820 9316 would be the part number from 1972, but our equivalent is 74LS 161. So what we got going on is I've actually followed his board layout over here on right here on the right. So that has B2, B1, A2, A1. Which is confusing because B2 here, B1 here, A2 here, A1 here. This is mostly for my OCD so I can understand what's going on in the circuit. So CP is clock pulse. So that's being fed 125 kilohertz from our 1 megahertz oscillator. So it's divided down. So that should all be fine. And then TC is pin 15 on our A1 and B1. CP is pin 2. CET is pin 10. I don't think I have screwed with... Have I screwed with pin 10 on B2 yet? Let's find out. Yes. Okay, good. That is actually cooked up correctly in both of those, so I'm happy about that. And then these all are accepting inputs. So B2 has pin 5 at B1. And that's exactly what we have here. So this is good, this is good, this is good. All those look correct. And then from there it goes down to this flip-flop. So on the flip-flop side, let me think about how to window this. On the flip-flop side, that'll do. So here's his flip-flop here. This is a dual D flip-flop, and here's mine. So I've got 74LS74. His part number is a 1820-0077. So what's happened is I've got to go back up to my... I don't know if I can get this all in frame, but I can... Maybe if I zoom out a little bit, I can do it barely. Okay, so let's pull back up his schematic. And so, yeah, maybe, just maybe. So, pin 3 is connecting to A2 actually. So A2 comes down here, loop, de-doop, de-doop, to pin 3. And then pin 2 is connected to pin 6, which is connected to number 1 pin of my 74LS00 NAND gate. So that's all as it should be, and pin 2 is connected to that one, and etc. And then that goes all the way up over here to pin 11 of the B2. So that all makes sense. Q3 is QD, by the way. So again, it all is working okay. So that much is wired correctly. Now, I think I'm going to do a separate thing on figuring out what is going on with his keypad. But this is the circuit as it exists, and this is what I need to go and build. Sweet. Let's save this. And print a copy. I wonder if I got any paper in the printer. Probably not. Okay, well, I'm going to head off here. I'm going to set up my rig to actually tape me building the box again, because I got so many things wrong, it's ridiculous. But at least that will get me started in the right direction. So this is CPROS-U out. Yes, there's no paper in it. And I'll be on later, hopefully.